Okay, good afternoon, good morning, good evening, good night.
Hello. Just waiting. Yeah, we are live. So, how was your day?
My day was excellent, Manuel. We have 24 degrees here, good weather. I mean, we had. How was your day?
Great as well. I mean, I had a Bavarian breakfast. Good evening, Steve. Can you see the chat, Guido?
Yeah, I can see the chat. Yes, I see. Ah, yeah, I see Steve. Good evening, Steve. Yeah, and Gabriella. Good. Good morning, I think, or not? Yeah,
Argentina, nice.
yeah.
Yeah. By the way, does everybody hear us? Is Guido audible? Am I audible? Do we need to change
Yeah,
something? Please write it in the chat.
yeah. Test 1, 2, 3. We hear us.
Hello,
This is
Andreas.
Guido, PE1NNZ, talking to Manuel, DL2MAN.
Yeah, this is Manuel, DL2MAN, 599. No, 5 and 9 actually when we are talking about audio, right? Okay, chat is visible. Hello from Texas. Great. Greetings. Hi. Oh my god. There must be a nest somewhere.
Stuart asking me a question. Hello, great work for uSDX. I'm interested in the LF bands. I'm curious if the uSDX could be adapted to work on 160 and 220.
2,200 meters.
2000.
That's
Yeah,
audio.
that's what would it look like? Yeah.
Let's create a sound card.
Well, we can answer that a little bit later.
Yeah, sure. We're just warming up. Guys, don't wonder. Guido and me are talking very often, and it will be very loose here today. We just two guys having some fun, and at some point answering your questions, or maybe in between. Perfect. So everybody seems to agree on the audio quality. So we are visible and we are audible.
Yeah.
Perfect. So here we are. And we wanted to talk a little bit about the uSDX, probably because that's what we are known for, right? Should
We
we?
want to talk about the past, the current, and the future.
Yeah, should we start with the history? I don't know if people are interested in that, so we can walk through the history if you like.
Yeah. Oh.
I even have, I think I still have it somewhere. I just need to pick up the box because I had a speech very recently for the GQRP club, and I showed that them. So everything should be all together still.
Yeah. I have here a practical thing. This is how it all started, at least for me. I didn't met Manuel yet at that point, but I knew Hans from QRP Labs. He sold this unit, the QCX, and that was for me the inspiration to start thinking: can we do something else with it than only CW? And so I started modifying it into an SSB transmitter in the first instance. That was first actually not done on the QCX, it was done on an Arduino board. And then later ported to this QCX because I saw the potential of this unit. We were all waiting for the QSX, and I thought, yeah, the QCX
We are still
can
waiting,
be
by
great.
the way.
Okay, for what actually?
The QSX.
Oh yeah, exactly. But it might have been changed now. I heard that the QMX is now out, and I don't know. But
Seriously?
that yeah,
What
I
is
heard
it all
about that.
about?
What I know, it's an QDX and a QCX Mini combined. I think it's really great design what Hans did.
By the way,
and
just
Hans,
we need to shout out to Hans because he always does great designs, right? He
yeah.
does that
So
puzzling thing.
this is the QCX Mini. It's really great design. I think he managed to fit and a QDX and a QCX Mini now in this kind of box. I think that's really great idea. And he's going to support SSB mode in the way how the TrueSDX is doing that, or the microSDX. So that's still experimental. It's not there yet, but that's the plan, I understood. So I think that's really great. But to come back, we started with the QCX, modifying it, and suddenly we had not a CW transceiver, but an SSB transmitter. And from there on, I also started then to remove more and more components. You see that actually a lot of these QCX components have been removed by actually doing more and more in software. And this became actually a full-blown SDR, just still with an Atmega chip on it. And that's when we met, Manuel. And you had some requests, right, about CW and things.
Yeah, it all started with me having built a QCX and really liking it, but I was missing the AGC because the behavior of the QCX was when a strong station came in while you were working a weak station, it would immediately blow your ears out. And I didn't like that, so I was basically researching an AGC for the QCX and stumbled upon your project where you said that AGC was one of them because that was one of the keywords in it, right?
Yeah.
And I saw, hey, he did like DSP stuff in there. How can that be? So I wrote Guido an email asking, because the project was named QCX SSB. And I was not so much interested in SSB. I'm still most of the time working CW. And so I was asking Guido, hey, does it also work in CW? And what was your reply? I can still remember.
Of course. Yeah.
His reply was, you should try it out then. And the rest is history. So
Yeah.
I said, okay, this guy replied to me. Great. Step one done. So I bought another QCX kit and tried to build according to Guido's instructions. I tried to build one from scratch, basically from a new kit, and built a QCX SSB. I think we had some back and forth then already, right?
Yeah.
Talking about what I need to do and what not. I think it was about the details of your instructions.
Yeah, exactly. Maybe I can show a bit how that looked like at that time. Okay. Yeah. Okay, this
Give me a
is
second.
how it looked. Yeah.
I'm going to. What do you want me to show?
Maybe just this screen. This was the old GitHub page that we had initially.
I only have the left side because the chat's in the way. Okay, I'm going to put the chat now over your face. I'm sorry.
Okay. Yeah.
And I think it's still not working. Ah, yeah, okay.
It doesn't really matter. I mean, I just want to show the original schematic. Here, this is the QCX schematic. And this is, oh, wow, that doesn't work anymore. One sec. Need to go back to my, oh, this is not my own. Doesn't matter. This is already the modern version. I want to show the modifications that we did. This is in the end the schematic. This is the complete schematic actually. So you see a lot of the things of the QCX actually not in use. It's only the Atmega, the display, the PLL, and the mixer, the switch. And then Manuel said, yeah, but yeah, this is not really class E what we're doing here, low pass filters. And yeah, this then we started then improving these filters. We had experience with the series LC, the series class E topology.
I think that was
then,
later.
Was that later?
Yeah.
Okay.
I mean, in the beginning.
Oh yeah, in the beginning we had the.
Yeah. We had a talk. Okay, I'm going to show our faces again. 1 second. Maybe you just can stop sharing.
Yeah. Okay. Stop.
Okay. So now the chat's in the way again.
So lots of new people joined. I see Dirk from Sweden. Hello. Christian. Clive. Yeah.
Jan is there. Hi.
Yeah. Yeah. So
57 are watching right now.
Yeah. And John is also there. Yeah. All right. So so from there we started improving the hardware, the filters. We had first the original the shunt resonance. How do you call that?
Well, I'm going to pick my box real quick so we have something to show. Okay.
Yeah. Yeah. So yeah, so it was actually just this board with only these wires on the back and actually not a lot of components installed that actually made then the whole SDR and SSB functionality on just actually a CW transmitter.
Okay. I'm going to go a little bit full screen with me now. Why are you smirking? What's going on?
It sounded quite.
When I was. Okay, I'm going to show you a view in my box. Okay, so Guido, I'm going to make myself big here. Guido was showing you already the original QCX. That was that. And right next to it, I'm going to show you the QCX SSB according to Guido's modification. And this is how our cooperation, can I say that, started.
Yeah.
Because I started a manual, basically, describing how to build that in a more easy way, can I say, or a more digestible way, let's say like this.
Yeah.
I tried to write that down for people. So that was the beginning. And when we talked the first time, very early on, we had the idea that because, as you can see, there's a lot of parts missing. There's lots of parts missing. So all that space is unused. So why not have a dedicated PCB for that. And that was the beginning of the, I think we called it uCX? No. MicroSDX. Yeah, that's also very, what you showed, people can see, I'm sorry. This is also very late already.
Yeah.
The very first one, and that's a unique thing. I think nobody has that. This here was my very first I/O board. This here is my very first main board, and together with that I had my revision 1 RF board.
Yeah.
As you can see with an error, because you can see the FETs on this side, but the marker for the FETs on this side. This is why it never got really released. I immediately started another revision of the PCB, and this was basically the test run. We saw, I'm going to make myself now smaller, try to have us both visible at the same time. I'm sorry, I'm not very good with this OBS Studio software I'm using. I'm doing this not very often, and I'm not sure how to do that all in real time. Okay,
Yeah.
so we are both visible again. Yeah, so these are the very first 3 boards that I designed. Basically, it started earlier. If you remember, Guido, I've drawn the schematic, leaving out everything we didn't need. Taking basically the QCX schematic and leaving out everything we didn't need, and we talked very early what we wanted to have in there. And then I had my schematic, and I think this is what Barb, WB2CBA, was using to design his uSDX, right?
Yeah.
Please correct me if I'm wrong. From the timeline, that was the thing here.
Yeah, we at that time also the group started to form, and there were many actually people collaborating in their own ways. And yeah, that is the board that Barb designed that you show you now. I think that was the first board that Barb made, if I remember well.
Yes.
But there were many others that came with all kind of ideas, and still that's still happening actually as of today. Yeah, but we continued, and we started creating the sandwich. That's this one. That's the
Exactly.
next version.
I think there was, we created the sandwich, that's right. We had at least this I/O board, what Guido was just showing you with the big LCD, because we found out that the OLED was a little bit small. Do you see yourself, Guido? Can you see what people are seeing?
I can see it, but it's not so bright maybe. But yeah, it's a big display, an LCD display. It's pretty expensive display, but it's not an OLED, and it is also not the traditional LCD that was actually used on the QCX. But it was a smaller form factor, and it was the size of a credit card, right, Manuel?
Yes.
That was the idea, and it was much thicker than a credit card, of course. But that was because we used that modular design. We had a filter board, we had the controls board on the front, and we had the CPU board with the with the receiver on it. Yeah, that together was also the first experiment for this so-called series resonance class E.
But we have skipped a step here.
Okay.
Let me find it. Because the world's first multiband class E was this PCB. this one, where we shared we had 3 slots, but for 5 bands. This was also already a 5-band board, but we were using Hans's approach, parallel resonance class E, and this needed some very special relays with a lot of contacts. That was the annoying part of it.
Yeah, and Jer mentioned here in the chat also that at some point the QCX was then also launched with that daughter board. That was also a little bit later than that.
That was actually in the time where the thing you had, because I was sending Hans the same thing as I sent you. Exactly.
Yeah.
The QCX Mini.
This is a modified one. There are a few people who did do that. They installed this little daughter board that Hans also supplied in the kit, and fully on your own responsibility. Then you could modify it into a full-blown SSB CW rig, still using the Atmega processor and all the other hardware in it, except the filter boards, the op-amps, etc., were then actually bypassed. Worked really great. It was single band, by the way, at that time.
Yeah, then we were experimenting with serial resonance class E, which is what also modern TrueSDX is based on. It's basically, what did we use? I think a suggestion by NM0S, which used only 2 coils per filter. That was intriguing because it made band switching easier. So I designed a new RF board which had only 5 bands, 5 relays on it, and 2 coils per band, which is what you know from the TrueSDX as well. And later, that was the pinnacle of the uSDX project, of the sandwich project. I had this 8-band board.
Yeah.
But it also had a drawback, and this was we had only a very, very tiny FET on there, SOT23. So whenever SWR got bad, sorry, I need to find the window. It's really hard for me to talk while I'm playing with that software here, sorry. So I'm not as fluid as I would like to be.
Yeah, in the middle there, there's that tiny FET, and easily to be blown with misadaptions. Yeah. So we changed that in the releases afterwards. We went for this FTT 86256. And
okay, let's stop here because we are jumping over a giant leap here, because that was the pinnacle of the uSDX project. That's when things went downhill or bad or good, depending on the point of view. So we had that 8-band board. By the way, everything was designed in a way so it could be modular. So we can swap out single PCBs and not needing to rebuild everything. There was later the release of the OLED board, which is now closest, I think, to the TrueSDX. This is the uSDX sandwich pinnacle, basically. And there was the diet sandwich.
Yeah.
And by the way, this was also the time where I started designing this housing. We never had a housing before. We never thought of a housing before.
Yeah.
And that's basically the story of the uSDX. How we developed it.
And it was all supported by the software that's available on GitHub, are still available. And there were many flavors actually, as you see, with displays and relays and all kind of things. And that single source file actually supported it all. there were many options where you could then flip the switch to either say I want an LCD or an OLED, or I want to have this kind of I2C driver to control the low pass filter boards, or have this kind of setup for low pass filters. All kind of potential variations you could there configure, and then build your software in Arduino Studio, and then upload it to the Atmega processor. That was a bit how that all went and worked. And that modular approach, that configuration approach, that worked well for all these hardware variations. And there were also a lot of experiments done in that setup. And
It was always thought of as an experimentation platform. So because
yeah.
we never knew where the journey would go, and we wanted to stay as open as possible for all kinds
Exactly.
of
And
experiments. I'm sorry.
and also maybe good to say it was experimental, because the techniques that we're using also quite are not very regular used in the amateur world. We're using a Class E driver, which is then modulated by some envelope control to control the strength of the SSB signal, and the phase control for the information in the SSB signal. So this is so-called EER elimination of the envelope, and then restore it again. And that's all done in software and in hardware. And it's a bit difficult what I explained, but this EER technique, it was believed that it would never be good, actually, never be good for commercial rig, because there are quite a few challenges in it. But I think that, actually the commercial world is using this a lot, actually. Mobile phones using it as well, I guess. But for SSB modulation, this was never tried and believed to be quite problematic because of the non-linearity behavior of a Class E amplifier, etc. So, but because of that, it was an experimental platform, and we tried to continuously improve that. And as of today, we are at a point, I think, where we overcame a lot of problems, and and made it really working well, actually.
And went way over the top of what we thought was possible with the Atmega chip, right? We are beyond that point already.
Yeah. It was also, we keep using the Atmega to show the world that actually you can do a lot with less bits, because there was a bit of a tendency that the faster ADCs you have, and the more bits you have on the ADCs, the better. And that's of course true, the better in terms of performance, dynamic range, intermodulation behavior. But with this approach, we showed actually that with less bits, you can actually do also quite a good thing, quite a good transceiver. But with the use of smaller bandwidth, keeping the design such that actually the quality of the rig is still actually up to a level where it is quite usable.
I want to use the opportunity to address a chat comment that's simply ESP32. Nothing more, nothing less. ESP32, that's the comment. So I think part of the DNA of the uSDX, the TrueSDX, is the fact that we are only using Atmega. That's the whole point about it. Of course, we can do better with a higher end processor, but the thing is, can you do it with less? That's the whole idea behind it. I mean, everybody said it wasn't possible, and yet here we are.
Yeah, it was also a way to see if we can make a signal processing stack for software-defined radio that is actually capable, that's so optimized and capable to have the minimum set of functions for QRP radio, by using minimal set of resources. And that has a few good things in it, because by doing that, you also basically use not so much power for processing all these signals in the microprocessor. So that's it was also a challenge to see how far you can go to the minimum and to see what you can get out of that. And yeah, as you see, it's quite well possible to do something with an Atmega. And just to give you an idea, because 8 bits, that's what we're talking about, 8 bits processor with 10 bits ADCs. You think of that might not be suitable for any serious RF processing, but yeah, 10 dB of 10 bits is about 60 dB range, dynamic range. But by techniques like oversampling, etc., you can widen that a bit up. And by using very small filters on the mixers, you can also prevent large signals from interfering with signals in the ADCs. And also by looking at the overload behavior and optimize that, you can actually have a very decent performance behavior, even if it's in overload state. And that's what we have now.
Yeah, and another thing why the Atmega was so intriguing, or keeping that, not just for historical reasons. It was there in the QCX, which is the source, where it started for us, as we just explained. But the other thing is the Atmega is very, very low in power consumption. And that's another thing that went into the DNA of the uSDX and the TrueSDX. We wanted to have as low power consumption as possible, because I had a commercial radio at that time that was the FT818 or FT817, both the same basically. And the FT818 would draw 1 amp on receive. Can you imagine? 1 amp on receive. I can do 10 watts with the TrueSDX output with 1 amp at 12 volt. Imagine.
Yeah, and that's becoming more and more harder with other processors, like the ESP32 that's mentioned. I built, before this rig, I built actually an SDR based on the ESP8266, and this thing is drawing almost 200 milliamps or something like that. But of course, the Wi-Fi, etc., was also used. So there you see that the clock is, of course, much faster. It's 180 megahertz or something like that. And you can do a lot more in that, but it also consumes a lot more power. And yeah, for QP radios, that's not a good thing. So yeah, Bill asked, have you tried to use something else than the Atmega? Well, in the TrueSDX, I have tried something else. And where is it? I've actually never talked about that, but it's here. I have here a modified TrueSDX board, and maybe you can see it here on the side. I don't know, Manuel, can you see that? It's a bit dark, right?
You can see that, but I try to improve your screen.
Behind the display, there is a Pico board, a Raspberry Pi, Raspberry Pico chip, RP2040. And this thing also works. It has a, I can show you what it is doing if I connect it. Here. It's actually beeping a lot.
Is the smoke normal, Guido?
I don't know why it's beeping. There's no RF board connected. Oh, so you see, it's actually still operational. Yeah, it's a Pico TrueSDX basically. That's what I tried. Why I tried that? Because I was curious. What happens if you go for a faster processor? And the ADCs are supposed to be a bit better, but they are in practice not better. They are a bit the same or a little bit worse than the Atmega. So yeah, but of course, normally you would just add a codec to get just a very high performance ADC. But I didn't do that just to see, how far you can go then. And it's working better than from a dynamic range perspective than the Omega, but it works also not better in terms of noise behavior. So there are all kinds of problems actually with this change and challenges. So that's what for instance we tried. We have also something in mind for the future.
So we are jumping the present.
Well, I don't know. We can still talk about the present. I just talk a bit randomly about here and there. I see a lot of new questions coming in or talks.
QRP lifestyle. Hey, David.
Yeah. So that's right. The uSDX has about 80 milliamps in receive. There is a possibility to feed that with the nice battery pack that David.
No, that was my design.
That was your design, yeah.
David has a different one.
The one that's on the side.
Yeah, exactly.
And you can also use a USB power supply and feed it with 5 volt, or you can just use the 12 volt input. Yeah.
I see Cathal Ferris is in the chat. Please get in contact with me. Send me an email. We need to talk. John West, hi. Great to see you here. You applied the QRP philosophy to both the hardware and software of the radio. Minimalist, inexpensive, small, simple, but functional. Yes. And that's also what we figured when we talked about the future of the uSDX. We figured there's also already a lot of high-end rigs out there. So why go high-end? We have set a niche that I think is well appreciated by the community, because there are a lot of radios out there. And I think we should stay in that niche instead of trying to do something like Zygo or what's out there, K2 or something like that, or Lab 599 or name it, or even IC705. We don't want to go there. We want to have ultra portable, low power, simple radios that are affordable.
Yeah, the minimalistic approach, keep things simple as possible. That was really the basis, and that's actually still the idea. That doesn't mean that we want to reduce the performance. That we don't think about that. No, but we want to keep a simple radio.
Hi, Steve.
Hey, Steve. Yeah, good afternoon. Nice to see you. I see a question from Bill. I've read the source code from the SSB modulation. It seems to be magical. Could you give a high-level overview how that works? Shall I do that, Manuel?
I would say we can absolutely do that, but I would go with the with the past, present, and future thing first, and then we can answer specific questions and go into much more detail if you like. Yeah. But just to wrap that up, what do we plan in the future? Basically, right now it's just ideas. We have not started designing anything. We have a huge to-do list, a wish list basically, that we gathered over the last 2 years, what we want to have in there. And it constantly changes. That's the fun thing about it, right, Guido?
Yes, because we get new insights based on what we learned from the weaknesses or the challenges from the radio itself, but also from what's available in the market. And yeah, that's true. It's changing all the time. So we have, for instance, now the idea to go for a setup where there is an ADC on board, And that ADC thing is all the time changing. We have now found a very high performance ADC with more than 140 dB, so up to 160 dB dynamic range, which is really, really great, which is completely over the top for this type of radio, this performance. But yeah, it's possible to integrate that. So that's one of the ideas to do maybe. Yeah.
So do we want to talk a little bit about our ideas to get some feedback, or do we want to have something
Now,
more?
I don't know.
Well, then let's close up here for the future. We are still working on stuff, on a follow-up of the uSDX. Maybe there will be one step in between, right?
Yeah, we can talk about the future. No problem, Manuel. But maybe I was thinking it's good to give a bit of background how things are actually working, or what is actually the current. What are the current challenges?
Okay.
And
Yes.
what are
Yes. Please.
maybe
Then let's jump directly to the freestyle part and talk about whatever you like or what the audience wants to hear, because
yeah.
we have you here now. By the way,
So
thank you, Guido, for
yeah.
doing this with me.
Yeah, thank you too, Manuel. I really enjoy it to be here, the guest in this talk. Or guest, how do you say that?
You're
We do
basically
that
host.
together, right?
Yeah.
Yeah. So yeah, what is good about this radio is that it's very compact, and that it is, as Manuel already told, drawing very little current. It has a lot of functions in it. There are 5 bands currently supported. You can swap another filter board in it, and then you can also cover other bands, the high band boards, filter board, for instance, or the low band filter board. And you have also the classical band board, which then skips the
May I
wide
interrupt
bands.
here? Because there is a
Yeah.
question specifically about that. Hi, as a German E-class ham, I'm still confused how to order the right uSDX version for 10, 15 and 80 meters. The Alibaba shop is quite chaotic from my perspective. Any advice here? Okay, because Guido just mentioned the 3 different band versions. We have the low band version. This is standard. This can be bought as completed rig and this has only the low bands, 80, 60, 40, 30, 20 meters. And this can be bought as completed rig. Then there's 2 additional PCBs. That's only RF PCBs. They can be bought in classical bands version. That would be 80, 40, 20, 15, 10, which is probably the most of what you would need. So you would need a classical band version in that case. But here comes the drawback. The classical and high bands versions are not available built because there's a lot of tuning involved. I don't want to make you afraid, or I don't want to give you fear of that. It's absolutely doable, but it needs to be done for each and every board. So it cannot be sold as built unit because it would not be affordable anymore. I hope this clears it up. So you need the classical bands version because it covers at least 3. Yeah, it covers all 3 of the bands you want to have in one board.
5 bands. Yeah.
No,
Yeah.
he was asking for 10, 15
Okay.
and 80 meters, and all the 3 bands are on the classical bands board, but you need a main board as well. You can also buy, I think, a classical bands kit, and this means you have the main board to build yourself and the RF board, the classical bands in that case, and you can build the whole thing. And I have a video out how to build that. It's not complicated. Just look at it, and I have a separate video of how to tune it. That's also not complicated. You just need some basic tools that are very affordable. So
Yeah.
sorry for the interruption.
Yeah, and how to order that? I think Manuel has on the website a link to the suppliers and also to the group buyers. Suppliers is, I think, Sunny. He supplies that on AliExpress.
Exactly. Here comes a pro tip, by the way. AliExpress is one thing, eBay is another thing, Amazon is a third thing, but what those three platforms have in common, they all earn money from Sunny sales. And if you want to bypass that, then go to the fourth link, which is her online shop. There are no platform fees, so she will sell it to you cheaper. That's
Yeah.
And you can trust her, as we do.
And the link is also on your website, Manuel?
Yes, absolutely. It is on my website. It's the new DIY tech.
Yeah. Okay.
Sorry, I
Yeah.
interrupted you. You wanted to tell something about the background, I think.
Yeah. So maybe just yeah. Okay. I was talking about the good sides and the bad things of it. So it's lightweight, little power consumption, 5-band support, but only 5-band support. The high bands are covered well, they working well. Sensitivity is also quite okay, but there are limitations. You cannot go to 6 meter, for instance. That's absolutely not sensitive enough for that. And there are also no filter ports for it. So that's a bit where the limitations are right now. Yeah, other limitations are on the software side. The microprocessor firmware is completely full right now with all kind of functionality. There is a lot of functions on board, CW, SSB, all kind of supporting functions like Vox, that it's speech enabled, PTT driven. There are QSK modes for CW. There's a keyer in it, all kind of keyer modes with different speed settings. There's a message beacon in it that you can pre-program CW messages. There are...
Because you mentioned the Kia, Guido, there was a request, I think, 2 times about a certain mode. I don't recall what it was because I never used it.
The automatic.
Yeah, exactly.
Mode, I think. Yeah. This can be done. The question is, do we have the bits of free space for that, and is it worth to add it then compared to the other functions? So I don't know yet if that will be added or not.
Yeah,
but
I just ask you. So it is in theory possible.
yeah.
It was never in there because there was also a claim that it already was in there. And
No, there are only the iambic A and B currently in it.
Exactly. And I don't know if so many people are using that. So that's what I would be interested in. How many people are using the Ultimatic mode? Is it worth it? Sorry for the interruption.
Yeah. So yeah, there are also other functions in it that we are now currently busy with to enrich the CAT interface so that the audio can be streamed over the CAT USB port. I can show you that a little bit later, maybe. Yeah, so as said, it's quite complete for QFP use, but there are also filters in it. All kinds of filters for CW from 500 Hertz to 50 Hertz. That's pretty small. And also for SSB, you can switch from 4 kilohertz to about 1.8 kilohertz. Of course, all these filters are made, they're pretty sharp, but the suppression around, I'd say that at some point these 8 bits really become a limit actually in terms of processing power, and that means that the filters are quite good for for in the normal CW use. But if there's, for instance, a very huge contest ongoing with large signals around, then you can actually at some point see the limitations of these filters, and then you can still hear the nearby signals around these filters. So that's where I think a better processor can help, and where a new rig can actually improve. Also from a usability perspective, the display is actually very small. If you see it, it's you all probably know it, but it's pretty well readable inside the home. Oh, I think it's going on and off. It's pretty bright here in the room, but on the other hand, in sunlight, this is maybe a little bit difficult to see, and the display is also pretty small. So for a future rig, this can be probably improved by using, for instance, such kind of display. The brightness of this display is not so much better, but it's at least bigger. So that's where we think things could be improved. Manuel, just to add something, if you think.
Yeah, right. As I said, we are talking in all kinds of directions. Display is one of the points we're going to address. Then we probably will give up some efficiency on the RF board for easier, how should I say, tunability or buildability. So because everybody has learned now that Class E can be quite tricky and quite hard to tune to get it right, and I don't know how many FETs have blown now worldwide because we started this project. So we are going to have probably a little bit of a different PA setup, sacrificing a little bit of efficiency for more usability. That's another direction we talked of. Then we had some, I think the form factor will stay same, and we want to have more bands in the next version, I think.
Yeah, and an overall technology upgrade, that we support faster USB, that we have USB-C support, that you can just use battery packs, USB battery packs, how do you call that?
PD, power delivery.
Yeah, PD. But also 3.7 cells. We don't want to go for an approach where you transform down from 12 volt to lower voltage inside the rig. No, we want to do it the opposite, that you're actually going from low voltage to actually the voltage is needed in the rig. And because the PA actually need higher voltage in some cases, and that's where this boost function we can combine with the regulation of the envelope. So that's one thing we want to combine. Other things we want to do, it was also mentioned here in the chat, like we see on SSB transmit some bad audio. Well, the dynamic range of the SSB is limited, that we know, and we think of adding an additional mode where the PA will be used in a different mode where the quality can be improved. That's a new idea. It's too technical, I think, to detail that now out.
You can name the headline. I think it is called drain modulation, right?
Yeah. So basically, currently what we're doing is we control the envelope and the phase. That's the way how the SSB signal is actually formed. That's all done in software, and in hardware, in analog part, this comes together. The envelope, the strength of the amplitude, and the phase information of the oscillator. So basically, what we're doing is we tuning all the time the oscillator, and by retuning it, we change slightly the phase of that oscillator signal, and then add then amplify it in the PA at the level where the envelope is set. And that makes then in the end the SSB signal back. That is that EER technology that we are applying. the limitations currently are the granularity of the way how we can set that phase in the PLL. And the other limitation is the level of the envelope control. But that's not a major factor. The major factor is the way how you can set the phase angle. And to further improve that, we want to also adopt phase modulation in the in actually 2 different envelopes, and then combine it to improve that. I think it's not very clear what I'm saying, but that will
Doesn't
be the idea.
matter. It's it shouldn't get too technical. Let me just show the chat something. Guido, by the way, you are not visible right now. I need the space.
Okay.
Just for the people asking in the chat here. 1 second, where is my chat? Here it is. Questions like, did I hear that the classical bands version does 10 meters? Everything you need to know about the uSDX you can see on DL2MAN.de. And there's this uSDX menu. And you have all the basic information in the first, basically 2 menu items. The group by is a little bit misleading because it contains everything, or it was thought for the group by organizer. But here are all the technical details, how to order that, how to order parts for that, substitute parts, everything's on there, everything's open. And the next page is the uSDX assembly. And here you can see the alternative band setup. And there is the description of what's available. The classical band version has 10 meters on board, as well as the high band version has. Okay. Now, Guido, you're back. You're visible again. Sorry. Just wanted to point that out. So, because not everybody knows of the page, but we put so much effort in it to document as much as possible. So I wanted to show that. All right. Do we want to reply to a few questions, maybe?
Yeah, that's fine. I see that Thierry is asking if I'm growing hops in my backyard.
Sorry, I was distracted by my beer.
No, it's not the case. It's a wild garden.
Yeah, some people need nature.
Yeah,
and I'm included in that. There's a question really low down, also CB, and the reply is no CB. Well, yes, it is possible, but we do not specifically support that. You can tune to 27 megahertz. You can, with the old software, you can do AM, FM. I think there was a restriction. I'm not sure because I never used AM or FM. It is not as sensitive as it should be for CB, and it should definitely not be used for CB, as it's an amateur radio. I mean, in an emergency situation, it's something else. You can tune it there, but you shouldn't do that. It's not meant to be there. But technical, it's capable of.
Yeah.
So I'm going to scroll a little bit up because there's also already a lot of questions here. There's what, greetings, interested in low frequencies. Maybe we go into that real quick.
Yeah. Yeah, it is an interesting question. Currently, the limitation of the rig, because of the low pass filter bands ports, is actually the 80 meter band. That's the lowest band we currently support. Below that, there are a few challenges that needs to be overcome on the PLL side, and there are a few tricks that I invented where you can actually run two PLLs or actually two clocks actually at the same time, and then create a phase shift that's actually needed for IQ processing. That's currently out of the box, not supported by these PLLs. The limit is something like 3.2 megahertz. Everything below, you don't get the 90 degree phase shift that you need. But there is this trick where you can actually apply it, this phase shift again, and then you can go lower in frequency. So theoretically, this is possible to support. The question is, from the RF side, will the PA be able to support, and do we have enough space to wind these coils, and because they become very big, and that's something we have never tried, and that's something we can explore.
The question would be, I mean, this will now sound arrogant. Usually we do stuff that we are interested in, we do like, because in the end it's just a hobby for us. I'm not sure if I'm so much interested in that, because I don't see the value, to be honest, of a QRP rig for the lower bands. Maybe that's just me, and imagine the kind of antenna you need. I don't even do 160 meters, to be honest. I'm not sure about you. I have transceivers for 160, obviously, but I have no antenna for it, and I'm not planning to have one.
Yeah. Well, what could be interesting on the low frequency QRP use is maybe to use the Whisper or other QRSS modes that are available. That's maybe the option I see as a QRP rig. And you can maybe do that, especially outdoors where you have the room to make big antennas, Manuel. But yeah, it's unexplored terrain, to be honest.
Yeah. So at this point, I would to reply to that question, I would say at this point we have no plans going on the low bands with the uSDX or its successor, right? If there will be a future possibility, we will explore it, but at this time we have no plans going there.
Yeah.
There's another question, I think, that can also be seen in the context of what we just discussed. Can I change the uSDX logo to my call sign using the uSDX.ino for the uSDX Plus V2? Let me start. What is a uSDX Plus V2? That is completely out of our control. That's probably a Chinese rig, a Chinese clone. You can change that, but you need to use the source code and you need to be able to compile it.
Yeah. Well, I think that's the question. Maybe can the uSDX open source code be used and compiled just as a private person, just as an experiment, and can you upload it on the uSDX?
No. The question was specifically for the uSDX Plus V2. That's a Chinese clone rig.
Okay.
And they come up with different names every day, so I'm not keeping track of that. I'm not tracking record. I have no clue what rig can do what changes everybody. That's the main problem with the Chinese clones, is that they never really document their changes and give something back to the community. So in the end, it's about us saying no, we are not going to support it because we can't. But if you're fit, you can again go to my website. On the top, you can see it right now, is the uSDX sandwich page. scroll down to software, and there's the description how to modify the source code from Guido, including the link to his source code, and you can play around with that. Okay. AGC for the QCX became an add-on board. Okay, didn't know that. I think because we...
Yeah, that for the QCX. Yeah, that's right. Yeah, that's a hardware solution. Yeah, what we did is to make an AGC function completely in software, and also by using the hardware in a way where we use the RF switch and the ADCs in a way where we also use the attenuation. We use them as attenuators, and that combination of AGC function in software and these attenuators makes what it is.
By the way, just to make you nervous, Guido, we have 83 viewers right now. So... let me see. QCX Mini released.
If I'm doing POTA in a park, I only use 40 to 20. Is it possible to build a filter board from 40 to 15 meter? You can only do that by using then either an yeah, I think a classical board, right? And then populate only these classical band filters.
I'm sorry, I didn't read the question because I'm scrolling through the chat here and trying to figure out what answers are not replied yet.
Yeah, it was the question on the last.
Okay, I'm going to mark this now so I know where I was.
Okay.
45 thumbs up, yeah. Jan, make them. Yeah, please, if you like that, if you want to do us that more often, leave a like, man. Leave a like. Leave a thumbs up. So what was the question? If I'm doing POTA in a park, use 40 to 10 meters. Is it possible to build a filter board from 40 to 15? On principle, yes. I don't think the software does support that. Well, 40 and 15 would be the classical band board.
Yeah, but then you don't have support for the WARC bands like 17. Yeah. So yeah, that's where you either have to choose for if you want to have that WARC band support, you can only use either a high band or a low band version. But if you are satisfied with just the classical bands, then you can just populate only the filters
Danke, Jan.
that you mentioned.
Danke.
Yeah. I see Steve also has a question. How can we as a community make your and Sunny's life easier? That's a good question.
Don't buy so much rigs.
Yeah.
Seriously, we didn't expect that to be such a success. Seriously, I mean, we started just as a fun project, and we thought, well, like with the uSDX, a few people would build it. There would be a few group buy organizers to support, and they further on would support all their buyers, and it would be an easy thing. So this is why we agreed to do support of all of that, and we didn't expect that there would be tens and 10,000s of rigs out there. This is crazy, man.
Yeah, no, but actually, so we have always been working on with the community, and the community has done and supporting a lot also in the forum and expresses their ideas, the limitations, the problems, the future.
No, don't send money.
No, I think that's not also not the right thing to do.
Don't send beer. No, beer to me. But independent of that.
But seriously, I think it is a ham radio community, and from that angle, I think these helping on the next steps is actually, I think, one thing that can help us also out. For instance, the discussion we have now about the future rig, I think that input is very valuable, and that's where we need a community as well to get it. And maybe the contribution there as well. I mean, there
That's
are
a
from
valid point. Guido, actually, you're making a really good point here, as this would be really of great help if the community, if the experienced people in the community that have experience in building a true SDX, troubleshooting a true SDX, support the community, people that ask questions, that have not so much experience, would just support them. So we get a little bit, how do you say, entlasted, relieved,
relieved,
unloaded,
yeah.
yes, yeah.
Yeah, but also on the software side, yeah, the open source portion that we originally had with the micro SDX, yeah, while it was open source, there were a few contributions, and that was actually quite valuable, but it was very limited. So I think it would be much more helpful in the end if also people contributing on that side. But of course, we are a bit in a difficult situation there right now, because we need then to find the right way to collaborate there. Yeah, but that definitely is something, because now currently it comes basically only on a few shoulders, and that's yeah.
Okay, I'm going back in the chat. I could not believe that you even build a spectrum scope with the new firmware. Amazing. So that's not a question. That's a thumbs up for you, Guido.
Yeah, thank you very much. I'm also very happy that we succeeded doing that. And I think the way how we implemented that is also a pure fit for this type of radio. And it's a very different way how you do that normally, but yeah, I hope people enjoy that feature. Yeah.
Okay, what do we have? 8-bit microcontroller, yes. I think we have replied to that. I've read the source code SSB modulation. It seems magical. Could you give us a high-level overview of how it works? High level, would it be too much for now? Do we want to go through easier stuff now, or do you have time? Do you have what do you think?
So from the transmit side, or in general, what's the question exactly?
I've read the source code for SSB modulation, and it
Okay,
seems
just
magical.
modulation. Yeah. So yeah, I already highlighted a little bit. So basically, it's not so easy to explain, but the way how it works with SSB modulation, normally you would just mix up an audio portion, and then pass it through a filter, and then mix it up to the frequency where you want to transmit. That's not how we do it in the true SDX. The way how we're doing it is directly actually put the oscillator on the frequency where we want to transmit, and then actually slightly modifying the oscillator signal by changing the phase and by changing the amplitude, and that's actually all controlled by software. So how is that basically done? In software, we receive the microphone signal that's just coming into one GPIO pin on the Atmega processor. Then we have the audio signal coming in. And the first thing we do is we measure the strength of the audio, and we measure the phase of that audio signal. And we do that by means of an Hilbert transform filter. And I don't know if I can share my screen. Then I can show you how such filter look like.
Sure, I will make myself disappear and make you big.
Okay. Okay, this is the schematic. Well, here you see actually the filter that we're currently using. This is the Hilbert transform filter. On the left side, you have negative frequencies, and on the right side, you have the positive frequencies. And you see that there's some kind of attenuation of about 60 dB between the left and the right side of the frequency. And that's basically what this filter is doing. It splits negative and positive frequencies from each other, and by using phase shifts. This is used on the receiving side. This is also used on that microphone signal that we getting in. And basically only the right side is used for the transmission. And that portion, we reconstruct that by using phase changes and amplitude changes from it. And then controlling the SI5351 PLL and controlling a PWM signal on the microprocessor pin to control the amplitude of the transmit signal. I know this is still not understandable what I'm telling, but this is how it goes. Yeah, so here in the schematic you see actually here the PLL, which is controlled by means of phase changes. And here you see the PWM signal coming out of PB2, and it's then actually controlling the envelope of this PA transistor. And these two things combined gives the SSP signal in transmit. Yeah. Now on the receive side, something similar happened. We just have here the PLL switching these mixer on the receiving frequency, and then you get here actually, because this is actually oh, you see my mouse now? Uh, okay. The FST3253, that is actually the switching mixer. That is the oh. Oh, that's the reason. Okay. Oh, one sec. I will move my I will remove a bit my screen. Okay. Is it now visible?
Yes, now we see the FST3253.
Yeah, it's a bit smaller. So here you see the mixer basically. That is actually switching with about 4 times the speed of the receiving frequency, and then loading, charging these capacitors with the receiving signal. And these are so-called I and Q signals, and they are basically then amplified and fed to the ADCs of the Atmega processor. And then the ADC is basically then doing all the signal processing. It's also performing that same Hilbert transform that I just showed you here. So it's actually on the right side past the receiving frequency and actually attenuate on the left side the other portion of the SSP signal. Because if you mix a signal, you get actually, yeah, that both the left and the right side portion of the mixing frequency then actually will be demodulated, and you would hear both of the that's not single sideband, that's double sideband. So you want single sideband, so this Hilbert transform filter then filters out only one side, and that is then happening with about 60 dB or 70 dB or more attenuation. And then some kind of um, additional signal processing filters are used, and then the signal is then finally sent out again with PWM modulation on the speaker. And that's basically all what happens. The processor is very busy with that. It's actually continuously loaded while doing that. But there's still a little bit time left then for the menu and all the control functions. So if you press a button, that's still working in parallel with all these other processes. Yeah, that's basically what's happening behind the scenes.
Okay. would you I would
I
now
will.
end your.
Yeah, stop. Okay.
Okay, great. So now your full screen. I'm visible again. Yep. Now I would love to find my chat back. There it is. There's a question. Before future, yeah, see what we've missed. Before future, can you tell us about the evolution from 1 to 1.1 to 1.2 hardware? What op-amp replacement and what capacitors added so tolerance is not so critical?
Yeah.
Maybe I can take over. Let me see. From 1.0 to 1.1, that was actually this fix here. Guido, yeah, okay, I should show you a schematic of that. Maybe I'm going to do that. So Guido, would you be able to distract them so I can pull up the schematic?
Yeah. Oh, that's this mod that I made, right? Yeah. Okay. So that was actually the first idea for 1.1. We experienced originally quite a bit of, not quite a bit. We experienced here and there some spurs over the bands, and we were actually wondering where that was coming from. That was one thing we experienced, and the other thing was that if you put the volume above a certain point, I think it's about 13 or 14 in CW, and on the higher bands where it is very quiet, and suddenly you hear a kind of beeping sound, kind of feedback. That were the two problems we originally were experiencing.
Okay,
I
I'm
think
going
that's
to pull up the schematic now. So what we did on revision 1.1 was actually splitting the VCC from the 5-volt line. That was the 1.1 revision, and everything around the microcontroller is on the VCC line. Everything else is now on the 5-volt line, and this is what we do. We are separating the microcontroller from the receiver part. That was Guido's mod. So what about the op-amp? The op-amp was simply a bad pick or a bad batch that only showed itself the problem with that batch we have received. We tested it up to 10 meters and we saw, while it was overall more quiet and better, that it would not perform on 10 meters. So we started to investigate, and while Guido was going the systematic and software approach, I just removed the op-amp, the LT6231, and replaced it with a one from a good batch I had, and could see the problem was immediately gone. The symptom was there was simply no reception at all on 10 meters, and we had no idea why that was. It would block itself. And Guido would research then that there was a buildup on, what was it? The plus side, right?
If you show a little bit of schematic to the left also, Manuel, then I can better explain it.
Where do we...
If you move the schematic a little bit to the left or to the right, I don't know.
Yeah.
Okay.
Use the CX340 or...
Yeah, I want to see the mixer as well. Okay. So basically the problem is that there are tiny variations of DC voltage that at some point start building up over the QSD capacitors. And then, yeah, this is the CH340. Yeah, okay. So what then happens is that basically the op-amps, because of so much gain, is basically steering out of the range, the working range where it can actually normally function. So the cause is huge gain that we actually need to amplify the signal that is suitable then for the Atmega. That's one thing. That with the combination with the problem that there are tiny offsets created over the QSD capacitors, and that is actually caused by timing differences that are happening on the high frequencies. Now Now, simple solution for this is basically just to decouple the op-amp input from the QSD capacitors. Then you actually solve that problem.
Which is what is being visible here. C38 and C40, they do exactly that. But this is revision 1.2. Revision 1.1 did not have that. That was introduced on 1.2.
Yeah.
And another thing that was introduced in 1.2, and this is the only difference, that's that polyfuse and that reverse polarity diode. That's it.
Yeah.
Besides
So,
that, they are the same.
So to sum up, what we fixed with all this, with the 1.1, we have fixed that beeping feedback sound on the higher bands that we had. We have solved the spur problems. Yeah. We have also solved then the polarity problems. If you power up the rig with the reverse polarity, and the fuse will temporarily interrupt and not damage the transceiver.
Which was demonstrated in a video by me, and that
Yeah.
made me sweat.
Yeah.
Okay, now let's go further through the chat. Okay, that's it. German Class E replied to that. Weak speaker, yes. That's also a thing we have on mind. The next will definitely have its own op amp. You're
Well,
welcome.
I must say, Manuel, with the version 1.2, we have the capability of higher audio output in the current setup, and it actually works much better in that sense. So, yeah.
Guido,
Okay,
please
then.
cut the grass.
Okay, I see another question, Manuel. I'm not sure if we should handle it now.
I'm working my way through the chat, so hopefully
Yeah.
we will catch up soon.
Yeah.
Probably some notes about this. Okay, no, that was. Oh yeah. Alter anything on the RF board or just on the main board? Only on the main board. So
Yeah.
you can swap your main board for the 1.2 version, but it's not really a need. You can modify that, and the reverse polarity protection can be built in the cable. So you do not need to buy a new main board.
All these boards are still fully compatible. Yeah.
And you can modify it.
Yeah.
As Guido was showing here in this mod, this is the full 1.1 mod. If you have the right op amp, there's no need to put the blocking capacitors on, and the reverse polarity thing you can do in the cable. That's my whole point. It's just makes sense for new buyers, but or if you cannot build at all or solder. If you can solder, modify it, be good. And I remember when David was here one time, he asked me, "Oh my God, why does your radio sound so different?" That, my friends, is the secret. I replaced the QSD capacitors with tantalum ones. That's why my radio sounds different. Way less cracky, now it's messing with my speech. Way less cracky, crackling, less noise, cleaner overall sound. Just solder them in and find it out for yourself. You will like it. And watch for polarity with the tantalums, of course. And yeah, there might be also in the next revision, we might have a place for bigger capacitors, so you don't need to buy the expensive 0603 ones. You need to get a nano VNA when you order uSDX. You don't need that, but it's definitely helpful. Community, yeah, we talked about that. Steve, it would be really helpful if you experienced guys could support the less experienced guys in the forum, so we have a lower workload. We have pretty experienced guys now helping out in the community. Okay. We have a lot to catch up. Questions about processor. I don't think we should go into this, as it's. Is there an advantage running the Mega 2560 processor, Guido? Current raw memory? Question marks.
You can theoretically replace it with that type of processor, and then you have much more memory. And there are a few things you need to do in the software, to change in the software to keep it compatible. If you want to try that, you can do that with the open source microSDX software and then experiment with it. And there are people actually already doing that in the forum. So that is, yeah, possible.
Okay.
But it's difficult, hard to obtain part.
Then we have a question. He has a uSDX 1.2. RX is very good, but SSP TX is very bad. Any solution? This is too broad. Sorry. For one, I'm not sure if you mean the true SDX or do you mean uSDX?
Yeah, the uSDX, we are using 2.0 in the true SDX. So this must be 1.02. This is probably just the open source micro SDX. Probably used by the Chinese vendors as well. They use that version. They modified it a bit here and there by configure certain switches. Unfortunately, they enabled an experimental feature, so-called quad, which makes the audio a bit worse than it could be. What you can do is just go to the website, install the open source software, and make sure that quad function is disabled, and that is by default disabled.
Rob Cell needs a high band version of the TrueSDX urgently, as he's more active on daytime. If he should wait, he asks, or for soon released improvements or not. So, no, don't wait for it. A clear no, as we don't have a schedule. We are talking now for 1 year about improvements, and we are still not in that direction. And RF section, the TrueSDX as it is will still be valid. And as you just saw, you don't need to buy a new 1.2 mainboard. You can fix that yourself. No, don't wait for it. If we do something new, it will be a different thing. Transflective display. Yeah, that's also a good point here, Bill. The replacement FETs are cheap. Try not to choose expensive one. If you do, yeah, that's also my point. We realized that the FTT 86256 we are using on the high-end classical band boards are a little bit hard to get. And we had samples that were not usable at all. I tested them in comparison to good ones from Mauser, and they did not even, they were not even close to the numbers from the data sheet. So that's also something to consider. There are a lot of fakes out there, and that's the same for BS170s. There are reverse polarity BS170s. It's hard to not stumble upon fake parts these days. Hey, we have someone from South Africa. That's nice. So, do we have Antarctica here? Then we could, and Australia, maybe. That would be nice. Then we would have all continents. We have that.
Yeah, the classical bands supports 10 meter indeed. Yeah.
Yeah, we'll contact you soon. No CB. West Cannabis. The uSDX page is one of the best parts of the project. Knowledge is king. Yeah, thank you. I know it's chaotic, and there was a suggestion later in the chat if I should do a troubleshooting manual, but I don't want to do that. It's simply you cannot satisfy everyone, and it's a lot of paperwork. I'm not so much into paperwork. So this is, by the way, a fun fact. This is why I started videos. Because it's easier to explain something when I show you how it's being done, even though my English might be hard to understand. Instead of sitting there documenting it, this is a very dry process, while creating videos is very, yeah, it's a living thing. Try to post. What link did you try? Jesse Brown. Did I miss something? No CB. Okay.
So Bill asked how easy it would be to make VHF for 2 meter. Well, everything can be done, but the problem is it's actually not so easy because the oscillator itself is not very suitable for that type of frequency. It is possible to reach that frequency, but the phase noise characteristics on that frequency is probably not sufficient. So you need to go for a different PLL. Okay. Then, so John is actually saying that he loves to receive LF in the USA, but he also believes that it's important.
Steve wants to buy us a beer in Friedrichshafen next month.
That's always good to drink a beer in Friedrichshafen with friends. Thank you, Steve. Yeah.
Okay, I'm going to QRX here because I need light now. 1 second.
Okay, I will take over. How many true SDX kits have been assembled and rigs have been sold? Now, we can see how many registrations have been done for the two SDXs, and that are about 15,000, right, Manuel?
Sorry, back again.
Yeah.
Say again?
So there were 15,000 true SDXs sold. Yeah.
At 10,000 we know for sure that there's more than 10,000. It's in the region of 10 to 15,000. We don't know for sure the number. Why is that? Because there's a lot of fake serial numbers from earlier or double serial numbers that were never deleted, of chips that smoked away and were registered new. So we don't know for sure. We cannot know for sure.
And this is actually then the total amount of group buys and rigs that are sold everywhere through all the vendors that were there.
And by the way, just to make that clear once again, you do not need to buy from Sony. You can still build it for yourself, and you will get access to the serial number pool. There's no restrictions. If you want to build a rig, you just write us an email when you try to register your serial number. We will unlock that, and it's good. No questions asked.
Yeah. And there are many people, right, that do that for their club. They build 5 or 50 or 30 batches, and they build it all together, or they build it individually. That's also happening. Yeah.
Oh, Julian is also here. Good evening. OH8STN.
Ah, yeah.
He's going to take a TrueSDX with him to the Arctic.
Very nice.
Julian, if you're still here, maybe you can write in the chat when this will be, when we can work you. That would be really interesting.
Yeah.
And then we will see if the uSDX holds up in Arctic climate. But I think Julian has an oven. I don't have sound on this computer. That's a good question here. Do you know if the parts Sunny uses are authentic versus good enough that work well? So, what we know for sure is that Sunny doesn't use amidon cores, but she sent us the cores she was using and we approved it. They were even better than the original ones. And usually whenever Sunny is changing something, she sends us a sample and we test it. And we had the cases where we said, no, you cannot use that, like in case of the FTT 86256. There were from Taiwan and China. They didn't work. That was the case I mentioned before that did not fulfill the datasheet values. So we said her, no, you cannot use them. Use Mauser parts. And she bought them, and yeah, that issue was gone. So usually Sunny is acting proactive. Julian answered, we are arriving 36, I think it's 26th of May, perfect. Packing up 28th May. So between 26th of May and 28th of May. Please, guys, you probably all know Julian, Off-Grid Ham Radio, OH at STN. Check out his channel and watch him. He's doing crazy great stuff, and we all want to be where he is going to be, hopefully. Yeah, exactly. I did not know tantalum caps have polarity. Yeah, they do.
They do.
They are like electrolytics. Okay, 10 microfarad. Just go do the 10 microfarad caps, C38 and C40. Go on just the plus line of the op amp. Are they ceramic? Do they need to be NP0? They are actually quite uncritical. They can be X5R. They are simple blocking caps. DC blocking caps. They can be anything you like, and they go to the plus. Let me check once again. If you follow that, no, they are actually on the minus. Pin 2 and pin 6 of the op amp. You can do a screenshot now or a screenshot later, or the video will be online, so I will just leave that for a moment so you can copy that. Okay, I hope the question is answered. Do we have more questions? The link to the store for the high band kit. Okay. High band kit. Let's go to product list. Those are the kits. High band, full kit.
Okay.
Click, copy, going to the chat and pasting it here. And now we need Guido back. Here's Guido. And I need my chat window back. If you both go 4 days in May next year. Make sure Hans and Farman are going that time also. What do you mean by that?
Farhan, yeah. Of course.
What does Farhan have to do with us?
Well, these are the great designers, Manuel. All the QRP rigs
I get
out
it.
there, and that would be great to join up together.
To 4 days in May next year. But do you mean Friedrichshafen with that? No.
4 days in May is in. It was last week. Would be great. Yeah.
Where is that? I don't know of that.
I think it's in Dayton area.
Oh, I get it.
It's
I don't even have a passport, guys.
it's the place to be for QRP.
Can I drive there with my car? Then I will be happily there.
Okay.
Yeah, well, never say never. Manuel, your English is imperfect, but better than most Americans. Also much better than my Hochdeutsch, yeah. What do you think about new QMX from QRP Labs? I need to pass on that one because I don't know it really. But I see it's Bora. Yes, he's one of the lucky winners of the 1.1 TrueSDXs.
Now, I can say something about it, Manuel.
Yep.
Yeah. So I think we already started with it in the beginning, but I think it's a great design. So what Hans did is combining the QDX and the QCX Mini in a design where it actually basically all fits together, and that's a great idea. It's also multi-band, and he's planning to also incorporate the same SSB algorithm that basically I invented. Yeah, so that's, I think, really great that the technique will be used and applied on more places. I think that's really interesting to see, especially because the hardware itself is also more capable.
I will definitely have a look into that, and actually I should go to Friedrichshafen and buy one. I should send Hans a message that he should bring one if it's available. Because even though I have a QDX, even though I don't use it, I usually buy everything just to support him for one, and the other thing is to see what crazy stuff he's doing again. Link, please, of the best low-cost SDR TRX. Well, I've sent that link here. Is there any way you could add an LED setup so we could tell if we are talking loud enough and not loud enough? Not sure.
I'm actually experimenting with that right now.
Oh.
Not sure if that is actually. I can actually show it even. Maybe.
Wow, guys!
It's very.
We are making history. Never seen before footage.
Well, it's a bit dangerous because I have no dummy load here, but.
Oh. Do you want to get one? So we will put that to later.
Yeah, it's actually, I can show you this. If you, I think this is the. Here you see an indicator. If you make, you see here, it's an indicator that starts changing when you modulate. So yes, there is something happening on that area. Not sure if that will be fitting in the final firmware, but
Guido, always crazy stuff. Always crazy new stuff. I like that. Any possibility to changing the power connector to more common 2.1 millimeter? Yes, absolutely, but probably not in the uSDX. The next thing, definitely. A little bit about history of that thing, of the barrel jack, I think it is being called. Before that, we had, okay, so now I'm making Guido small again. In the beginning, we used the same terminal connectors that Hans was using, and I was asking all the time for, hey, give me a certain standard, and nobody replied ever to that, to me. So I took the one I could find that was available for SMT assembly in the factory and soldered it on there. I never wasted a thought on that. Now that I've learned that many people are using different ones, I would definitely do that. I'm not sure if it's possible to fit it on the, to do another release of the uSDX mainboard, if that makes any sense. Not sure. Any plans for a version designed specifically for digital modes? Well,
Yes.
that's our cue, right? Because we wanted to show something. You wanted to show something what we are working on. And by the way, I like that Julian is here, so he witnesses that.
Yeah. Okay, maybe I show you then a bit the idea. There are many developments on this area, but the one actually I highlighted already is that we want to use the CAT interface and use that also for CAT streaming, as we call it. So instead of putting all kind of cables here on audio cables to your computer, we would like to use the USB interface to not only control the radio, but also to actually transfer the audio, the digital audio stream over the same interface to your computer. And for that, we made a little extension in the uSDX that enables that CAT streaming. The alpha version that has that actually implemented right now, and that supports then that you can stream the reception, the receive audio to the computer, and also vice versa. You can also transmit audio from the PC over the USB serial interface and then transmit in that
So
way.
the fascinating thing, the practical aspect of this, what this means is you don't need audio cables anymore. You're only using the USB connection to connect it to your PC, and even audio will be streamed via USB. That's the point here. Okay.
Okay, and I'm going to show you how that then look like. I need to share my screen again. In this case, I show my Windows machine. I think it's this one. I need to find it back myself, where that is on my computer. Okay, 1 sec. This is the demonstration effect. Okay. Yes. So I have here running WJST FT8 program. Currently it's searching for the radio. So I've just plugged in the radio on the USB interface, and I've here, not here, I've here a driver that I will start here, and then actually connects to the uSDX and enables this audio streaming feature. And if everything goes right, I can then, well, I can initiate that. Well, that is not, yeah, here we see that the interface is now initialized. And now I'm able basically to control it from the FT8 program. Oh, okay. I put them both a bit more right. So So here actually you see now there's no antenna connected to it, so you see just noise here coming in, and yeah, you see that it is tuned on this frequency. But if I start changing the dial, then this will at some point also change. Here you see it's now changed to another frequency, and I can also then change frequency from here to, and you hear the clicking of the uSDX to changing bands, and I can start transmitting and enable TX. Yeah, but I can just maybe show. I hope that the cable doesn't disconnect. It's a bit of a dramatic cable. Here, see then the uSDX. If
Guido,
I,
we can
yeah,
see you right now because we are seeing your screen.
oh,
I will take care of that. 1 second now.
okay. So if I start changing frequency, for instance, you see it also changing here. And if I start transmitting, I tune, for instance, here, you see it also coming into TX mode. Now, in this way, you can basically then use the rig without any audio cable, only by using this USB cable. And if you power it up this way through your PC, you have about a power of a few watt, or one, or half a watt, or
It's
1
a
watt,
half watt to 1 watt, yes. But you can
depend.
also power it externally, then you have the full 5 watt, but wouldn't do that without antenna.
Yeah, exactly. So I think this is a great way to start using FT8 with the uSDX, and it's also available on our Linux. Officially, this software is not completely released yet in terms of the binaries, but on my GitHub page you can already find the sources for it and run it yourself. But this needs to be finalized for a good installer. That will come at some point. Yeah, so this also gives some other possibilities. You can also stream audio. So if you have, for instance, some audio to transmit, you can write your own program and start transmitting this. There is on the DL2MAN website a page that describes the protocol that it actually then is used. And I want to show you that. You go just to the page and there's uSDX details here. And if you click on that, that's actually where it is explained which commands can be sent to actually stream or receive audio. And the way how that works is just that 8-bit audio is then transported over that CAT interface, and you can mix it with CAT commands, and yeah, the driver basically splits the CAT commands from the audio and sends the audio to the FT8 program via loopback interface. That's basically the setup. Does that make sense, Manuel?
Absolutely, yeah. And I just wanted to mention that there was a challenge. So if anybody who wants can write as a driver, we are inviting them openly. Well, Guido has now done majority of the work, and I'm not sure if we can talk about the work of Dan.
Yeah, we can. So Dan also develops a product, Pocket RxTX, and another product with another name. Manuel,
Yeah,
you
for
have it
Windows
maybe?
at least, I think.
Yeah,
And he also is. He sent us two versions, and we could see it's already using communication with DualSix, but not in that case as we are using it, or we are trying to use it for as a driver for other applications like Vara or whatever, or WJSTX like Guido showed you here, but as a remote control basically. He's using
yeah,
that, so you can remote
yeah,
control the rig.
and also Ollie SQ3 SWF has made a driver for Linux, or
He was
initially.
actually the first one.
Yeah, and I used his work to also make it possible for Windows. Yeah, so that's basically all community work, and that's great.
Okay, where were we? Okay.
So the other, I was actually not completely finished, Manuel. Maybe I can a little bit say more about the other ID. So besides this cut streaming thing, there is also an experiment ongoing to see if we can get a kind of mini FT8 running into the uSDX. But this is very experimental and not of any meaning yet. But at least what is there right now is that there is a piece of code with a completely stripped down transceiver, which basically fits in 16 kilobyte of data, and then you can still control it well and use it as a transceiver, as an SSB transceiver. So we have actually another 16 kilobyte left for this very
It's so
simplified.
stripped down that it even lost its lettering.
Yeah, it's
Look at the case. That was just a joke. The case you have in your hand. Show it in the camera, please. There's no letters on there. I was just making fun.
I didn't notice it, but now I get the joke. Yeah. No, but actually the stripped down FT8, actually you made a joke about it, but it will then also probably only understand support the basic message types that are used. I don't know if this is of any meaning and if people like that ID. It's just an experiment, and we don't know if this is really going to be released or not, but it's an ID.
Well, chat, tell Guido if you appreciate the idea or not. I'm going to read one question from Julian. One future feature request is integrated audio codecs like DigiRig. I think that is going into the direction you just explained, right?
Yeah.
Will the firm, yeah, Ultimatic, we have already replied to that before, Günther. I think it was because of you I asked that question to Guido.
Yeah.
Please watch the stream again. It can be implemented, but we are not sure if that's of any value to the rest. So we are not sure if we can sacrifice somewhere space for that. Okay, that's now the third time. 6 meter question mark. Right now, not possible. Okay, Guido, please, how do I access audio stream mentioned in the latest firmware? I would like to use it for JS. Yeah, I think we went just through that.
Yeah, so if you send a cut command like semicolon and then UA and then 1, so uniform alpha 1 and then another semicolon, then suddenly this cut interface starts streaming the receiving audio. Yeah, just look at that page that I just showed.
Guido, it was great to hear from you and Manuel. Thank you for hosting this, Manuel. If you did one of these brain dumps once a month, that would be amazing. Guido,
Yeah.
do we want to have public discussions once a month?
I'm fine.
Okay, so you heard it, guys. Hopefully we find a common date. Can you get audio via serial interface? It is additional. Yeah, okay, you know. If you can drive on water. I think most logical step for uSDX version 2 would be switch to 4-bit microcontroller. Hey, actually, I want to do one now with relays, only relays. You know, so we can do real debugging in the original meaning of it, like bugs between contacts.
Yeah, I agree. This is the right direction.
Is there an aluminium case for the uSDX? As far as I know, there is none for sale. I know there has been a few guys trying and even sharing their designs. So you might want to search through, I think it was published in the forum. Just look it up, look for aluminium case. And just to mention that, the housing license is CC BY SA. This means Creative Commons, name the source where you got it, share under the same license, and you can even use it for free, even for commercial use. So if anybody feels he wants to do a commercial aluminium housing for the uSDX, just do it. You don't need our permission. Just share your designs and you're free to do whatever you like. Any news on the driver to use here? I think we went over that. Guido said it was available on his GitHub. It's just not ready yet, but you can also already have a look into that. Exciting sneak peek, yes, I agree. Guido, your comment on that. A great feature, maybe trade a few CW message slots for it. I'm not sure what this is relating to, but a few CW slots will not give you enough memory for almost everything.
Okay.
Passed on the QDX because I can't do wide data modes, hoping that improves in the future. Yeah, it's limited, but I support my guys, you know, and it was interesting to see how I implemented diode switching of the bands. I learned that from him. I liked his push-pull amplifier. So there were actually quite some things I enjoyed seeing while building. Excellent to work on optimal modulation indicator for better transmit audio. Very good, thank you. Keep up the great work. We try. Hans used a special USB-C connector with through-hole mounting to survive mechanical stress for the QMX. Yeah, that's a great idea. Is it possible to take the new multiband RF board with the old logic board one? There is no new multiband RF board. You need to know the new 1.2 main board is only the main board. They are always backwards compatible. You can use your existing RF boards with that. And it's just a mod that you can do with your 1.0 main board. No problem at all. It's just the main board that changes. I would buy another unit with digital capability. We are talking about software probably here. Not new hardware. Software only change to NL-USB audio. Yes, it is software only. I'm sorry, I'm so back with the chat. Yeah, oh my god, we still have a lot more messages. I'm getting ready to start building the high band filter board. When adjusting the notch, do you recommend something glued to secure the windings in place to prevent from future trouble? You can do that when you're absolutely sure that you're there. Yes. I do not do it because nothing is more constant than change. But
Yeah. Okay.
Guido, do you feel free to chime in whenever you like? Guido.
Yeah, because we are so behind the chat, maybe it's because many questions are actually from. Maybe we should because this is all going about the USB audio hardware mod. No, there's no hardware mod. It's the software support.
This is why I want to work myself to the present. So hopefully we can catch up.
And of course I have a dummy load, but it's upstairs. It's not here downstairs. That's why I try to transmit without a dummy load, and that's actually it's normally going well.
What I can see is 26 source broadcast my screen. Okay. How many layers do the PCB boards have? 4 layers. Audio stream avoid the ASCII value for the that's a question for you. With regard to the protocol, does the audio stream avoid the ASCII value for semicolon in the audio stream output, since semicolon is the delimiter character?
So that's a good question. So indeed, the semicolon cannot be used as a character for transmitting audio, and that means that you need to skip it when transmitting audio or receiving audio. A simple trick is to use one character higher or lower behind the semicolon, and in practice that is not really a problem to do it like that. Yeah, but you need to skip it.
Okay, Rob, Cell, Manuel, could you clarify all changes to version 1.2? Did that, please skip back and watch it when available. We went through that in detail. I still have an unassembled kit I bought a year ago. Now it's version 1.2. Possible upgrade? Yes, there is. Please skip back. Oh, no, I lost again. Difference is not too big. You can do that easily.
But you can buy only a main board, right? For instance, if you don't want that.
You can do that. That's
separate.
no problem. But it's also not very hard to implement the changes.
Yeah.
Recommended hand mic. There is not a single hand mic that's plug and play. There is a video from me where I show you how I modify. I think it was, what was it? A Retevis microphone, because it has an active speaker inside. That's what I use. Is there any point to run FT8 on a TrueSDX? We have FT8 on smartphone now.
Yeah, that's true. So maybe this whole idea of trying to run FT8 all in the box in itself is maybe not really a good idea.
Definitely more interested in audio. Yeah. Greed. Monthly brain dump would be awesome. 8 bits is a byte. 4 bits is a nibble. Will you ever sell your own NFET half waves or a simple kit to go with the TrueSDX? Yeah. I asked you in a video before if I should do that, and I'm still in the process of thinking if I should do that. I'm not so sure, because there are many points that people made that I should actually do what I do best, and not load myself up with workload that prevents me from developing. Actually, we are right now in the exact same situation, because I cannot be creative because I need to support. And actually, at this time of the year, spring, I'm out hunting, enjoying wildlife, enjoying nature, sleeping out in the woods as I did a few days ago, and yeah, doing real life things, because I need that for my mental sanity, to be honest. I'm not sure. Maybe I will start with a light approach, so just basically trying it out, selling what I have, and if it's out of stock, it's out of stock. Is it possible to complete control TrueSDX from PC like Flex Radio, like complete SDR radio in the future?
Yeah. So with this CAT capabilities, you can already control it with all kind of software in that manner. But indeed, with the audio streaming features, it becomes even more possible to do such kind of things and make a completely remotely controllable radio. Then
Actually, Dan's software does exactly that.
yeah.
Pocket RxTX for Android, and he has a Windows software as well. I'm not sure what the name of that is. I'm sorry. I need to look it up.
Yeah. GRAC or so. Yeah.
Yeah, blowing up PA is easy. That comment about trading a few CW slots was for SSB audio level indicator feature.
Ah, okay. I see. Makes sense. Yeah, we can do that. I'm not sure how well all these message 1, 2, 3, 4, 5 for the CW messages, how well that is received. I mean, we can leave that out and use that space for the other features. Yeah, that's possible.
That's one for you. I just want to thank Guido for making the QCX and SSB radio that brought a lot of people to the ham bands.
Yeah, that's really true actually. That by this this SSB mod and this QCX in itself actually, I think we should actually thank Hans as well for creating the QCX. I think that together brought a lot of people, new hams to the hobby, and because it's so practical and accessible, it's relatively cheap and to obtain. Yeah, it has huge success for people starting in this hobby. Yeah. And it gives also new capabilities for people who are already in the hobby, and that's especially for this QP use, right, Manuel?
Sorry, I was reading the chat.
Yeah,
Again?
doesn't matter. Well, I think with the uSDX, we also have enabled people who would like to take their rigs onto a mountain. It's
Absolutely.
I think the only very lightweight, cheapest, highly portable rig out there that can do all these things together. And
It seems to be well received. I have here an interesting question. Your website has an 8-band RF board available, Gerber files. How is that activated in software if I build one? Now, let's have a look at that. We are here at TrueSDX, and you can, this is everything related to TrueSDX. When you go to the uSDX sandwich, you see the 8-band board. That's the former project. That's what I showed before in the camera. That is not compatible to that. That does not work together with that. Okay, the uSDX sandwich is an own project. The TrueSDX is the new project. There's only 5-band boards available. Don't mix that up, please. Train AI for being a support. Yeah, if it was that good. Hey, let AI develop our stuff, then I can enjoy more time in the woods. How about that?
actually, you can to a certain extent already ask ChatGPT about the TrueSDX. They know who ChatGPT already know who are the creators of it, and
TrueSDX,
a bit
seriously. uSDX, I know, but
also TrueSDX, and also about what it is about. And in that sense, it's possible to do it that way. Of course, it might be a bit too limited.
any plan to improve, reduce receiving noise from both hardware and software sides? We did that with release 1.2.
Yeah.
That really reduced receiver noise.
Yeah, and actually it broke a bit our promise, right, Manuel? We always said we are not going to make new versions out of it because we want to have one common standard. But we really felt that we really should do this.
That was an unsolved problem for a long time, and then you suddenly found out what the reason was for this speaker howling thing, and it was necessary because I felt,
I felt also bad. So many rigs out there, and then this solution should also come to the people. So
yeah. So basically, I was wrong, and I needed to fix that. That's not an upgrade. That's a fix, and that it also serves the purpose to improve the receiver. That was an accident. Sorry. Can we fix that by software? Make the receiver noisy again, please.
is that a question, Manuel?
That was a
Make
joke.
Receiver... Oh, make it noisy again. Okay. Well, that's simple. Adding the attenuators up, right? And
most issues can be sorted via Q&A. Yes, you would think so, but you can see even within this very short session here, we are now live for almost 2.5 hours, we have already repetition of things that have been answered before. I don't know if people joined later, but you see, even here repetition happens. I lose the serial key. Is it possible to update the firmware? Yes. Install a serial number, download a firmware for a different serial number, one that works, and then it will show you your real serial number. Then you download the firmware for your real serial number, and it's okay. The CQ message and one more message would be perfect. I think I only use those 2 slots, yes. I think from my point of view, even though I'm CW guy, I'm using the memory in my ICOMs very often, even to do full QSOs. I don't use it too much in the uSDX, to be honest. I'm just using it for CQ loop. But this is debatable. Thank you both. Gotta go dinner. Yep. Enjoy your dinner. Bye-bye. Second message slot I use for sending test. Yes. With SMA, is it possible to insert by default different connector? Well,
Yeah.
it is.
Currently, yeah.
But I think it doesn't fit. Hi, Stefan. It doesn't fit to the PCB. I mean, we have credit card size, and how ridiculous does a BNC connector look in comparison to that?
Yeah.
So we went for the adapter.
And yeah, the adapter actually doesn't make it much bigger, as you see, compared to just the default BNC, which is by itself already much longer, just for comparison. Yeah. Oh, I need to show it this way. Yeah.
Rob, that wasn't meant towards your direction. From American Continent, we joined later, and many of us didn't build our kit, but we bought assembled. Yes, everything is available for everyone. We have the forum, we have the Facebook, we have the different videos. So that wasn't meant to be rude. It's just a matter of fact that repetition happens, as not everybody is joining the same time. No offense here, okay? Are not tightly matched. Yes, that doesn't matter. The 0603.
Actually, it matters, Manuel. The QSD capacitors needs to be actually similar in order to get IQ suppression. But
I would
the
agree
thing
to
is,
that, but in practice, I just solder
yeah,
them in and they work better than the original ones.
yeah, that's right. The worst thing can happen is that in such case, because of the higher tolerance, that your sidebench rejection works less than with the. But as you say, it we didn't see that in practice.
I only use SMA cable with my uSDX, also SMA on the antenna side. Yes, that's why I have... By the way, Mosel Blues is Delta Golf 1 Juliet Alpha November, the guy that was friendly enough to send me his PCB, which started a whole journey from my side again. So that was the spark. And he started my journey into the NFET half-wave thing. It's also fun. And I have, in fact, somewhere here, yeah, I can show it. Uniform O1 antenna with SMA connector here. I'm a little bit too small. There we go. And as you can see, I have a BNC slot as well. But depending on the size, depending on the need, I build them either with SMA or BNC. And small again, and we see Guido.
All right.
Is there a link for SMA, B, and C connectors, as my kit didn't have them installed? I know I can get them here, but getting the correct one would be nice. Yeah, you gotta be sorry, Jan. That's not very friendly from you, starting a journey. How do I do that now? I don't have a link, but I know they are available on eBay, the adapters. Just look for the ones that are one solid body, not two different pieces. Maybe I can go to my box. 1 second. I'm going to pick it. So I'm making noise again. Can you all still hear me? Guido's nodding. But Guido hears me through a different microphone than you all do. Okay, so this is the two different types of adapters that are available. You can see this one is one solid piece. And this one is split. They both work, but they are mechanically a little bit more robust, and as you can see, they are a little bit shorter, and both are available on eBay.
Yeah.
Very cheap.
And I think Sunny includes them as well, right, Manuel?
Yes, yes, she does.
Yeah.
Okay. Your kit didn't have it.
So actually, I have a few questions for the community, Manuel.
Yeah, go ahead, please.
Because now we are in the end. So now we have the true uSDX. We have talked about the future and ideas about that. Yeah. So is that also your thought, or do you have something missing? And we think about to use a bigger display, more bands in one box, maybe battery included, a better speaker, a better microprocessor, all these things. So okay, there's Manuel showing the. Oh no, okay, that is a little bit behind. Okay, so is that yeah? So or do you have something maybe to suggest or to add here?
I just want to add here the discussion between Cathal and Jesse.
Yeah. Yeah.
Sunny usually includes them, yes, but I also had the case one time where I didn't have it, or it might be that she added that only late. So not including, not being included doesn't mean it's not from a legit source. Usually you recognize, yeah, how do you recognize that? It's not easy at all. Usually from the seller's name.
Okay, yeah. I see people asking if a big display should be it. Others say, yeah, more bands would be nice. That is bigger display, use more power. Exactly, that is indeed a big problem. So the smaller screen is actually also accepted.
Well, then let me add to your question, Guido, to the community. Do you really think, or do you agree to us that we should stay in that niche right now? Or should we leave that niche? Should we go for something?
Yeah, Manuel, you ask more like, should we go for a more advanced rig
Yeah,
and leave that lightweight, low power, low cost for more advanced? That's what
yeah,
you mean, right? Yeah.
exactly. And I don't see the sense of that because
No,
they
me
are
neither.
already. But I want community's feedback for that.
Yeah. Yeah. I also don't see the sense because there are already plenty of rigs out there that can already do that. And um,
With what?
but e-ink is indeed a good suggestion, but it's very slow and not suitable for waterfall displays. There is an Asian, yeah, I forgot the name, an other kind of e-ink. It's not really e-ink technology. It's in between e-ink and LCD, which could be of use. It's black and white. It's slow, but faster than e-ink. Also, still not suitable, I think, for real waterfall use. So, yeah. Then Christian says, especially the USB data streaming to get rid of audio is good. Okay, stay in this niche. Yeah, that's Gush is saying. Gush, thank you. And stick with
Just
what you're
wanted to
doing.
comment to Julian. A day readable display like e-ink. The thing is, they have a very low refresh rate.
Yeah,
We have them even here for experiments. I mean, this is an e-ink, but the refresh rate is substandard, I would say, for the stuff we do, like updating CW decoding and so. So we
yeah.
had that in mind.
So Rob says, yeah, screen port to an external screen. It would be too much to ask. Rick is already wonderful. Okay, that makes sense. Then Theodore says, that would be nice to have a 20 or 25 watt of power in a similar case. Yeah, that could maybe an ID. That could be an ID. There's no longer QFP, but as an extension, the batteries could maybe also still support that. The higher power, the more powerful battery packs. Does a brighter display mod with a linear voltage regulator increase or decrease the noise? Well, actually, the brightness of the display doesn't really affect the noise level as we have seen, right, Manuel? It is more the
It's
voltage on the
well, define the display. Do you mean with the
the
current
OLED.
OLED that we are using?
Yeah, yeah,
Then it's the charge pump
yeah,
we have deactivated that took care of almost all the noise. And the brightness, when you increase that, usually it should not increase the noise.
yeah,
If so, change your display, try to get it from another source. It will, from type to type, it will vary. That's
yeah.
usually more difference.
But the thing is also that actually with the new 1.2 boards, the impact of that OLED noise is also much less.
Yes, exactly, because we have split
Yeah,
the two
the two
power
power
supplies.
supplies. Yeah, so Fabio Isco says, yeah, it's the Sharp eLCD. That's exactly the one I was referring to. They are very difficult to obtain. At least half a year ago, I was checking. It might not be suitable because of that. But it's a really nice display. They have quite a few pixels and they're extremely low in power consumption and also relatively fast to refresh. Steve says price point is key, I think, with SSB is unique. Yeah, that makes sense. And then Anthony Clark, greetings from Eindhoven. Now that's very close by. Hello, Anthony. Come and drink coffee here one day. Are any plans for a dual conversion design, which would allow more gain? A dual conversion design. This would help with HEC tracking. Yeah, um, the receiver is actually already a kind of dual conversion, if I understand your question well. Um, And AGC tracking, we're already doing a kind of AGC tracking and using the attenuators on the hardware side. Maybe it's something we should talk one-to-one on this ID. I like that. Then Fabio says, like Pebbles. Yeah, that was the display, I think. Minus Plus says, robust PA, same small size. So that's again a bit, yeah, better PA or maybe more powerful or more robust. Yeah, but the same size. And then the off-grid ham radio OEH88 STN says stay with the simple low-cost UP radio. Yeah. So that's actually very clear, Manuel, right? It's most of the actually only responses are keep doing what we're doing. Stefan says, hey, maybe a modular design for switching the high and low bands was great. Yes, that is indeed very great, I think.
Well, I think the next thing should have all bands.
Yeah, that was the idea, but maybe Stefan means maybe we should keep what we have. But actually that was not the idea. Then Steve says, everyone has a phone. Then Christian said,
we had a disconnect right now. Please repeat what you just said.
Yeah, so Steve said, maybe everybody has a phone these days. Why not using USB or Bluetooth? I think that is a great suggestion. And that's something we also discussed, Manuel, you and me.
Correct.
To maybe extend the uSDX with that Wi-Fi or Bluetooth capability. And yeah, it's not entirely clear if we're going with that approach. And if that makes sense. But yeah, from a use case perspective, absolutely good idea. I agree with that. Christian says bigger display would be nice. I also think that is nice, but power consumptive, of course. Goes says again, there are case designs that are modular. That's okay, Stefan. Yeah, that is true. That's also something we can facilitate. Well, already facilitated that with the 3D printing, of course. It's also quite modular, but there's only one use for it. You just mount the case.
Yes.
But Manuel, maybe there are possibilities where we can have multifunctional use of it. That's maybe, I don't know, thinking out of the box. Then it's 8 STN says it was just an example. The daylight reading is an important part. Yeah, I agree. And we have seen people making all kind of extensions on the uSDX to shield it so that the sunlight's not interfering with the display. Yeah, that's also a possible solution. Actually, I think that the display that Sunny currently is using is not actually that bad. It's much brighter, as you see, than the previous ones that we were using. Like for instance, this one. I don't know. Yeah, on this camera it looks all bright, but actually it's much less bright. Then John says a cheap external PA can be added. Whoever wants it. Yeah, you produce the heart and the functionality add feature, so it doesn't have to be in the case. But maybe, yeah, maybe a small add-on that could be nice for higher power, or I don't know. TT says stay with the simple and low cost approach. Okay. And then yes says Bluetooth low energy would be a good fit. Yeah, that is true. And especially the low power aspect of Bluetooth low energy is important because this 2.4 gigahertz easily radiates into the receiver and interfere easily, as we know. So yeah. Then Sarah says it's a good. How good is the selectivity regard to the rejection of strong off-frequency AM and FM signals? Well, Sarah, this is a good question. There is quite a bit of attenuation by the filters you have for the higher frequency. So FM signals normally should be well attenuated and not leaking into the receiver section because of that. However, the AM signals is a completely different story. AM, especially the mid-wave or the short-wave signals that are all around, they actually will not be filtered by the low-pass filters and just actually entering the mixer part. And that could be a problem if your mixer is not good, like the NA, SA 602 or 612 mixers out there. This could be at some point just a problem if the signals are getting too strong. But we're using quite a sophisticated mixer, a switching mixer, the Telu mixer, or I shouldn't actually call it Telu anymore because Hans Summers found out that it's actually not Dan Telu who invented it, but a Dutch guy, PE1NNZ, I think, Graas or something. Anyway, there are many people who invented this mixer type, it seems. And this switching mixer is very good for handling very strong signals, also off frequency. So not only the on frequency signals, but also the off frequency signals are well handled up to interception points of something like 30 dBm or 20 dBm in that range, which is but it can still result in problems if you really live next to a medium wave transmitter, for instance, and then you just need to add some high pass filters in your antenna. But probably all your other rigs also have that same problem then. So that's a bit the long story of your. Good afternoon, good morning. Then the next.
Guido, I'm not sure
Yes.
if we are still live.
Okay. I still see the YouTube channel and I see everything moving.
Yeah, I see the chat.
Yeah.
But
I see also the video moving.
okay.
So I think everything is fine. Then I lost a bit track now. Oh, here Anthony says, I'm thinking of IQ demodulation works as but fixed to 8 megahertz. Then add a mixer using the third output for tuning. Okay. That's a good suggestion. An interesting idea. Then Jer says, I have trouble reading my phone in the sun. Yeah, that makes also sense. So which display will actually be good in the sun? Yeah. And then KB800A says, I'd like to see a vote. Obviously, this rig should stay very simple, low control and low cost. I'd love to see the new rig with more memory, a larger display. Yeah. Okay. Now we're almost there. Just carry on, says Danny. And PA says the uSDX was the first transceiver I dared to build myself due to trust in the good description and your support. Okay, thank you for that.
That's actually, I want to point this out. This was the whole point, offering it as kit, as easy as possible to get hams into building themselves. I mean, that's part of the fun of the hobby, right? We are the only group of people that are, excuse me, that are allowed without special permission to build radios ourselves. We should make use of that.
Yeah, exactly. And the fact that you have the skills to build your own radio and then It makes it much more pleasurable to use it as well.
Good
It's a
night,
bit
Julian.
yeah. Good night. It's a bit the IKEA effect, right? Build your own stuff and use it. Then have you thought about using diodes instead of relays on the filter board? Yes. And actually, I had made a prototype of that Wi-Fi transmitter thing. No, I made a similar kind of, let's say, micro SDX, but completely Wi-Fi based. That was a disaster because the Wi-Fi interfered on the shortwave receiver. So it was not a good thing. But I also used there for the transmit section the pin diode setup, and that makes things much smaller and simpler. And yeah, we can think of that. The drawback is, of course, the higher current use and also the here and there a little bit more loss, especially on the lower bands. It's also more prone for errors. So the relays are pretty good and stable. And actually, the nice thing is you hear them clicking when using, and that
And
is
they
also
don't use
something.
any power once they are switched. I really love that feature. Okay, they're expensive and big.
Yeah, because we use the latching
Yes.
relays. Yeah.
By the way, on the GQRP club meeting, one member asked me where I found those tiny, tiny relays because he never saw such tiny relays.
Yeah. So then Muscle Blue says he likes the modular approach to stack the modules like the battery, the PA, the tuner. And that's, I think, a very interesting idea. You had this kind of IDs for mobile phones where they plug in a camera, a battery, and maybe suitable for our transceiver as well. Something to consider maybe. And Sarah says, agree with keeping it simple to avoid creeping featureism. That makes sense, Sarah. But if we keep it too simple, then we don't progress, right? So yeah, then we keep what we're having now, Manuel. That's also fine, right?
That is simple.
Yeah, exactly. So yeah, we still think that we can do better, and yeah, I think there are already a lot of hints given in all kinds of directions where it can be better. So that makes sense. So
the
Anton
next
says,
thing is actually the most important point on the list here, I think. High SWR protection would be of huge value. And that was on our to-do list even for the true SDX from the very beginning. Maybe a little bit of history there. We were there at some point, or at least the step before that, right? We had SWR running for SSB, but it was not accurate and used a lot of space. And that's the reason why we stopped it at that point, right?
yeah. So yeah, that's indeed the thing. So that's point taken, Anton. That's a very good suggestion. And also, I think the real live feedback of the SWR and power during SSB transmit, that would be a good thing. Yeah.
Yeah, but I think this is due to hardware restrictions. I think the Atmega at this point, there's no way yet how we can make that in real time, because as Guido told you, it's really, really busy.
Then Theodore says, if you decide to go bigger, make a laptop-like case where will be a lot of space for big screen and big battery base will be requirement for stability of the radio. Okay. Then marketing mixture said, don't build a Frankenstein, stay as it is. That's very conservative, but yeah. Um,
A lot of "we are live" messages. Thanks for that.
mhm.
Julian saying goodbye. DB6SM, Stefan. We replied to that in the very beginning of the stream. Please watch it from the beginning.
Yeah.
Bill, I would love to see finer tuning for the reference frequencies. Okay, that why am I laughing, Guido?
Yeah.
Why am I
Well,
laughing? We had that.
I remember that at some point you found a solution, right? We had in the just from history, we had in the micro SDX 1 hertz steps for the reference frequency, and that means that you need to turn a lot before it was actually on frequency. And Manuel found actually a good solution for that. You used an an engine for that, right?
Should I make a joke? Yeah,
Yeah,
a power drill.
yeah. So, but okay. So at that point, we knew that we did do something wrong. So then we made the steps a bit bigger. And in the uSDX software, these steps I think are 100 hertz, I
100
believe.
hertz. Yes.
Yeah, that has the disadvantage that you cannot tune in between. Yeah, in practice, not a real problem, I think. But yeah, then 1 hertz would be insane. Yeah, that could be helped with a new controller based on a more powerful. Oh, thank you, Anthony. That would be great. Please send a mail to PE1NNZ at amsa.org. Maybe we can make some collaboration on this. Then Yer says the TCXO mod is very close to spot on out of the box, and that is true. And that we had also in mind for the new rig, Manuel,
Yes.
to use that. Okay, and I think then we are there. Yeah, Manuel, anything
We are
next?
through. So, since we are almost 3 hours on air, I would suggest we stop this, but we promise we will be back in like a month.
Yeah,
What do
we
you
do
think?
that.
Let's have a date then. Hey guys, thank you all for joining us. I didn't think that it would be so entertaining and interesting. Thank you, Guido, for joining me. It was really interesting. I mean, usually we have these talks without audience, but I think this is very interesting for the audience.
Yes. Thank you all very much for showing your passions, your ideas, your questions, and I hope it was an informative
I
session.
cannot bring my falcon next time because they are breeding, and every time I go to the cage, they are trying to rip my heart out. That is not healthy right now. But thanks. Cathal, I'm going to contact you. You said you contacted me. Thank you all.
All right. Thanks. Bye-bye. See you
Then
next
we are
time.
going offline. 73. Bye bye. Cheers, friends. Enjoy a beer.